there is a specific kind of silence that only comes after catastrophe. Not the silence of peace, not the silence of rest, but the silence of erasure. The silence of a world that was, and then, suddenly, was not. That silence settled over the northeastern United States in the early hours of March 13, 1888. And those who survived it would carry it inside them for the rest of their lives. But before the silence, there was the warmth. The first week of March 1888 was, by every measurable account, a gift. Temperatures across New York, Connecticut, Massachusetts, and New Jersey had climbed into the mid-50s. Some days, closer to 60 degrees Fahrenheit. The kind of warmth that tricks the body into believing winter has surrendered early. The kind of warmth that opens coats, that lengthens strides, that makes the city feel, briefly, forgiving. New York City in the spring of 1888 was not merely a city. It was a declaration, a monument to what the industrial age believed it could do. The elevated rail lines, the ELs, threaded above the streets like iron veins, carrying tens of thousands of workers above the mud and noise of the avenues below. Telegraph and telephone wires crisscrossed the skyline in dense, almost impenetrable webs. Hundreds of lines strung from pole to pole, some towers carrying more than 300 individual cables. Gas lamps flickered to electric ones. Department stores rose 6 and 7 stories. The Brooklyn Bridge had been open less than 5 years, and it still made people stop and stare. The city believed it had mastered its environment. That belief was not arrogance exactly. It was the logical conclusion of everything the previous 50 years had built. Steam power, iron construction, instantaneous communication across continents. Why would the weather be any different? Why would the sky refuse to cooperate with the momentum of civilization? On Saturday, March 10th, the Weather Signal Service, the primitive forerunner of what would become the National Weather Service, issued its forecast for the coming week. It read, "Fresh to brisk winds, with rain, clearing and colder." A standard, unremarkable forecast, the kind that caused no alarm, the kind that sent no one running. The forecasters had no satellite imagery, no radar, no upper atmosphere balloons carrying instruments into the jet stream. They had telegraph reports from observation stations, a barometer, a thermometer, and decades of recorded pattern. What they did not have was any way to see what was forming far to the west and far to the north simultaneously. Two massive air masses, one Arctic and one coastal, moving toward each other on a collision course that their instruments could not detect until it was already too late. That is the first thing to hold on to. The first open thread that will matter before this story ends. The Weather Service knew something was shifting, but they did not know what, and so they said nothing alarming. And the city went to sleep on Sunday night, March 11th, with its windows open. Sunday, March 11th, late afternoon. The barometers began to fall, not dramatically, not with any urgency that a casual observer would notice, but the needle was moving, and in the way that needles sometimes move just before everything changes. The temperature that afternoon was still comfortable, 48 degrees in Manhattan. Workers finished their shifts on the elevated platforms. Families returned from church. The fish markets on Fulton Street were busy. The ferry services across the Hudson and the East River ran on their usual schedules. By 9 o'clock that evening, the first rain began. It was ordinary rain. Cold, but ordinary. The kind of rain that sends people inside without drama. There was nothing in that rain to suggest what it was carrying. Nothing in its sound or its weight to announce what was hours behind it. Somewhere over the Atlantic, a powerful low-pressure system was charging up the coastline. And somewhere over Canada, a dome of Arctic air of extraordinary density was pressing southward. These two systems were not supposed to meet the way they met. The collision, when it came, would release energy in a way the East Coast had not experienced in living memory, perhaps not in recorded memory. At the Weather Signal Service Station in Washington, D.C., the overnight officer on duty studied the incoming telegraph reports. Pressure dropping in Washington, pressure dropping in Baltimore, temperature in Albany beginning to fall faster than expected. He noted the observations. He adjusted no forecast. He had no framework for what the numbers were describing. By the time he might have assembled a picture, it would already be happening. The rain continued through midnight. Then it grew colder. By 2 in the morning, on Monday, March 12th, the rain was turning to sleet in parts of New Jersey and Connecticut. The temperature was falling rapidly now, not gradually. By 3 in the morning, it was below freezing in much of the region. The rain hardened, the sleet thickened, and somewhere over the interior of the continent, the Arctic air and the coastal storm locked together into something that did not have a precise name yet. Something the newspapers would later struggle to describe. Something that moved like a living thing. By 4 in the morning, it was snowing. Monday, March 12th, 6 o'clock in the morning. The city woke to something wrong. The snow was not falling. It was driving horizontally. The wind had arrived in the night without announcement, and it was now moving at 40, 50, 60 miles per hour through the avenues. The temperature had dropped from near 50 degrees to below 10 degrees Fahrenheit in a matter of hours. That swing, 40 degrees or more in a single night, was not something the human body was dressed for. Not something the city's infrastructure was designed to absorb. The first workers who stepped outside on Monday morning encountered a wall, not metaphorically. A physical wall of white and wind that pressed against the body and refused forward movement. The visibility was near zero. A man standing at the corner of Broadway and Fulton Street could not see the building on the opposite corner, could not see the eel tracks above his head, could see nothing beyond the swirling, screaming white. The elevated trains attempted to run. This is important. The operators of the elevated rail system made the decision in the early hours of Monday morning to keep the trains moving. The lines were the arteries of the working city. Tens of thousands of commuters depended on them. Shutting them down was an economic and logistical catastrophe. And in those first hours, the snow seemed manageable. Disruptive, yes, but manageable. The trains moved, and then they stopped moving. The snow was not falling as snow. It was arriving as a dense, almost solid mass of crystals driven by hurricane-force winds. It packed into every gap, every gear, every coupling. It accumulated on the tracks faster than any plow could clear it. Within hours of the morning rush beginning, trains on the 2nd Avenue line, the 3rd Avenue line, the 6th Avenue line, all of them were stalling, slowing, stopping. And when they stopped with passengers inside. By noon on Monday, there were dozens of trains suspended above the city streets, immobile, packed with commuters who had boarded that morning expecting a routine ride to work. The wind was screaming at 60 miles per hour around the iron frameworks of the elevated structures. The temperature inside the cars, with no heat and no movement, was dropping steadily. The passengers could look down from their frozen perches at the streets below, and the streets below were already buried, already impassable, already a different world. The snow kept falling. Monday, March 12th. Early afternoon. By 1 o'clock, the drifts had begun. Wind-driven snow does not accumulate evenly. It sculpts. It piles in the geometries of wind shadow and obstacle, building against walls and doorways and the sides of buildings into shapes that can reach extraordinary heights in remarkably short time. By early afternoon, drifts in lower Manhattan were already 6, 8, 10 feet tall. The doors of some buildings were entirely sealed, not blocked, sealed. The snow had packed so densely against the frames that the doors simply would not open. The telegraph network began to fail. The web of wires above the city, those hundreds of lines strung between towers and poles that represented the nervous system of the modern world, was not built to carry the weight of wet, compacting snow in hurricane-force winds. The poles began to lean, then to crack, then to fall. And when the poles fell, they brought the wires down with them, coiling into the streets in dense, dangerous tangles. Some of the wires were live. Some carried electrical current. The streets were already nearly impassable from snow. Now they were threaded with downed live wires lying across the drifts like snakes. The telephone system went dark. The telegraph system went dark. The city, which had prided itself on instantaneous communication across continents, could no longer communicate across a city block. The horse-drawn supply wagons that normally moved food, coal, and goods through the city's arteries were defeated by noon. The horses could not move through the drifts. Some were found the following day, frozen where they had stopped, still in their harnesses, still attached to their wagons. The streets between the drift walls became corridors of absolute stillness. No movement, no sound beyond the wind. The storm was not weakening. The barometric pressure at the New York Weather Signal Service Station recorded one of the lowest readings in the station's history that afternoon. The storm was, in meteorological terms, deepening, intensifying, drawing in more Arctic air, feeding itself, becoming more powerful as the hours passed. In the harbor, the situation was worse. The Port of New York in 1888 was one of the busiest in the world. Hundreds of vessels of every kind moved through its waters daily. On the morning of March 12th, many of those vessels were caught in the open water when the storm fully arrived. The winds built seas of 15, 20, 25 feet in the harbor and the lower bay. Ships dragged their anchors. Some were driven aground on the shores of Staten Island, Brooklyn, and New Jersey. The steam-powered ferries that connected Manhattan to its surrounding boroughs, the same ferries that tens of thousands of commuters had planned to use that day, were either making desperate runs back to their docks or were already driven onto the banks. One ferry, crossing from New Jersey, made it to its Manhattan slip with ice forming on its decks and its passengers unable to stand in the wind. It was one of the last ferries to complete a crossing for 2 days. And still, the snow fell. By 3 in the afternoon, the accumulation in Central Park had reached 18 inches. In some parts of New Jersey, it was already approaching 2 feet. The city's famous grid of streets, that rational, ordered geometry that was supposed to make everything efficient, became a series of corridors between white walls, some of them 15 and 20 feet high. The workers trapped on the elevated trains were beginning to understand they would not be rescued quickly. The fire departments could not move their equipment. The police could not move through the streets on foot. Some of the passengers on the frozen trains had been sitting inside those cars for 6, 8 hours. The cold was severe. The wind was finding every gap in the wooden car bodies. Some passengers wrapped themselves in whatever they had. Some attempted to climb down from the elevated structures to the drifts below, a drop of 15 or 20 feet, and had to be helped, or fell. The city that had declared itself the monument of the industrial age was, by Monday evening, almost entirely paralyzed. Monday, March 12th, evening into night. By 6 o'clock, the temperature in Manhattan was 6 degrees Fahrenheit. The wind chill, though that term would not enter common usage for decades, was creating conditions equivalent to 30 or 40 degrees below zero on exposed skin. The coal supply was the next crisis. The buildings of New York in 1888 were heated by coal, and coal was delivered daily by the same wagon networks that were now buried or frozen. The hospitals, the tenements, the great hotels, the government buildings, all of them depended on continuous delivery. That delivery had stopped. The coal in storage was finite, and the temperature was not stopping. On the streets, there were those who did not make it inside in time. The accounts from the following days described bodies recovered from snowdrifts in residential neighborhoods. Workers caught between the office and home, sometimes no more than a block or two from their destination, disoriented by the whiteout, weakened by the cold, who simply sat down in the snow and did not get up again. The drifts consumed them. Their neighbors would not find them until the thaw. The total death toll from the blizzard across New York, New Jersey, Connecticut, and Massachusetts would eventually be counted at over 400 people. Some estimates reach higher. The number of deaths at sea, among the vessels caught in the harbor and the coastal waters, added further weight to that count. 400 lives erased in 48 hours by a storm that no one had predicted. Through the night of Monday into Tuesday, the snow continued. The wind did not relent. The temperature did not rise. The city remained sealed. There was no communication with the outside world. No trains were moving in or out of the major terminals, Pennsylvania Station, Grand Central, both locked under drifts that reached the second-story windows of the surrounding buildings. The food supply in Manhattan was finite and shrinking. By Tuesday morning, some shops had sold out of everything on their shelves. The price of a loaf of bread in the neighborhoods that still had any had tripled, then quadrupled, and then, slowly, on Tuesday afternoon, the wind began to ease. Tuesday, March the 13th. The snow stopped falling sometime in the early hours of Tuesday morning. The wind took longer to die. But by midday Tuesday, the sky over New York had cleared to a cold, brilliant blue. And what the sun illuminated was a world transformed beyond recognition. The streets were gone, not covered, replaced by a continuous landscape of white that buried the ground floors of buildings, that swallowed the fire hydrants, that erased the curbs and crosswalks and alley entrances and storefronts behind a blank, featureless white. The elevated train tracks were buried beneath drifts that had built up higher than the platforms. Some of the frozen trains from the previous day were still up there, still waiting to be dug out. The silence that settled over the city on Tuesday afternoon was not the silence of peace. It was the silence of a machine that had stopped. A city of 1.5 million people, the most connected, the most powered, the most modern metropolitan engine on the planet, had been reduced to near total stillness by 48 hours of weather. The cleanup would take weeks. The drifts in some locations did not fully melt until late April. The effort required was enormous. Armies of men with shovels working day and night, horse carts hauling snow to the river, the entire labor force of the city redirected toward the single task of excavating itself from the white. The financial cost was staggering. The human cost was irreversible. But something else happened in the wreckage of the white hurricane, something that would change the city, and then the country, in ways that the blizzard itself could not have predicted. The men who ran New York's infrastructure stood in the ruins of their systems and made a decision that would reshape the city permanently. The elevated wires, all those hundreds of telegraph and telephone and electrical lines strung above the streets, had proven catastrophically vulnerable. They had come down in hours. They had become weapons. They had silenced the city's communications faster than any enemy army could have. Within years of the blizzard, the push to underground the city's electrical and communication systems began in earnest. New York would dig. New York would bury its wires beneath the streets, inside conduits and tunnels, protected from any storm that the sky could produce. The process took decades. It was enormously expensive. It was politically contentious. But it happened because the men who made those decisions had lived through 2 days of darkness, and they did not want to live through them again. The storm also accelerated serious discussion about a subway system. The elevated trains, so proud and so modern, had proven that a city of that size and density could not depend on infrastructure exposed to the weather. The conversations that had circulated loosely for years became urgent after 1888. The New York City subway would open in 1904. Its origins are traced by historians to multiple pressures, multiple forces. But among those forces, unmistakably, is the memory of those passengers frozen on the elevated tracks, looking down at the buried streets of a city that could not reach them. And then there is the Weather Service. The failure of the Signal Service to predict the blizzard was not merely embarrassing. It was a national reckoning. The science of meteorology, the tools of prediction, the networks of observation, all of them were exposed as profoundly inadequate. The pressure on Congress and on the scientific establishment to invest in better forecasting, better instrumentation, better coverage was immediate and sustained. The transformation of American meteorological science that followed the 1888 blizzard is not a straight line, but it is a clear one. The investment began. The knowledge accumulated. The forecasting improved. But here is what has not changed. Not entirely. Every winter, somewhere in the temperate world, a city wakes to something it did not expect. A storm that moved faster than the models predicted. A cold snap that arrived before the infrastructure was ready. A system that the forecasters called manageable until it was not. The tools are immeasurably better now. The satellites see everything. The computers run 10 million simulations a day. The warnings come hours, sometimes days in advance. And yet the wires still come down. The trains still stall. The supply chains still snap under unusual cold. The most modern cities on Earth still reveal, under sufficient meteorological pressure, the same fundamental fragility that Manhattan revealed in March of 1888. The architecture is different. The technology is different. The exposure is the same. We have built our world on the assumption of stable weather. We have designed our power grids and our food distribution and our heating systems and our transportation networks for the range of conditions we expect, not for the conditions that a genuine anomaly can produce. The White Hurricane was, in the terminology of the science that would follow it, an extreme weather event, a deviation from expectation, a statistical outlier. And the century after 1888 has been a lesson in how quickly the statistical outliers become the statistical average, how quickly the extreme becomes the baseline, how quickly the city that believed it had mastered its climate discovers that the climate has other plans. The 400 who died in the drifts of New York and Connecticut and New Jersey did not die because the storm was unprecedented. Events like it had happened before, in other places, in other eras. They died, in part, because no one believed it was possible here, because the city had decided, on the basis of 50 years of extraordinary success, that it was exempt, that it had advanced beyond vulnerability, that the Industrial Revolution had renegotiated the terms of its relationship with the natural world. The storm did not accept the renegotiation. The frozen horses still in their harnesses. The passengers sitting in the dark on immobile trains 40 feet above a buried city. The bodies found in the drifts a few feet from their own front doors. They are not simply historical casualties. They are reminders. They are the cost of the assumption that the systems we build are sufficient for the world we have not yet experienced. The White Hurricane lasted 48 hours. The cities it struck are still standing, rebuilt, modernized beyond anything the people of 1888 could have imagined. The electrical cables run underground now. The subway carries 5 million people a day through tunnels that no blizzard can reach. The weather forecasts come with satellite precision and probabilistic modeling and emergency alert systems that push warnings to every pocket and wrist. And when an anomaly comes, when a storm arrives that is larger than the model expected, the city still goes quiet. The lights still go dark. The silence still settles. The same silence that settled over Manhattan on the morning of March 13, 1888. The silence that is not peace. The silence that is the sound of a system discovering its own limits. The question the blizzard left is not whether it can happen again. It is whether we are building the systems to absorb what comes, or whether we are still, quietly, secretly, making the same calculation that New York made in the warm days of early March 1888. I'm Muris, and I love looking back at the past so we can better understand the present. And together, we keep history alive.